So, what if I told you that the Big Bang wasn't an explosion at all, but like a mathematical glitch?
A glitch that literally forced space and time to swap identities.
Right. A moment where a completely intentionally broken rule in abstract algebra basically created reality.
It sounds like science fiction, honestly.
It really does. But welcome to this deep dive,
Huh.
because our mission today is to explore a framework that is just, frankly, audacious. We are going to look at a purely mathematical model that attempts to build a cosmology from the absolute ground up.
And by ground up, you mean starting with nothing but a totally novel extension of the complex number plane.
Exactly. Starting there, and somehow, through pure geometric logic, arriving at Sir Roger Penrose's cyclical conformal cosmology.
Which is just a remarkable journey to trace for anyone listening. I mean, we are essentially mapping the universe, but not through the lens of a space telescope.
No, we're doing it through the intrinsic geometry of an 8-component algebra. And we've got a really fascinating stack of materials to guide us through this. We are analyzing 2 drafts by anonymous author. The first is discussing the scaling function of the Lorentzian cosmological model.
And the second one is split quaternion, like extension of the complex plane.
Yeah, that's the one. And alongside all that underlying math, we are also looking at an open letter of review from the Nate LM podcast team, authored by someone going by the name One Nate.
So we have the proposal and the critique. And the premise we're dealing with here is dense, but it's really profound.
Very dense.
We're looking at a universe generated by a 4-tensor product, 2 real algebra. The central thesis isn't about, cataloging cosmic phenomena like galaxies or quasars.
But it's not observational.
Exactly. It's asking if the geometry of space-time and the specific expansion rate of our universe naturally fall out of pure abstract algebra if you just set up the initial rules correctly.
The idea that you can just write down a set of algebraic rules and then watch gravity and cosmic expansion emerge organically, it's incredible to me.
It is wild.
It's like finding a foundational error in the code of reality, exploiting it, and then boom, you unlock the developer room. So I want to start at the absolute foundation, the seed of this entire universe.
Because to build a physical reality, you first need a mathematical space to put it in.
Exactly. And the author of these papers starts by looking at a fundamental rule of standard complex analysis and basically deciding to shatter it.
Yeah, that's really the catalyst for the entire framework. If you want to understand the architecture of this specific universe, you have to look at the forbidden equation that initiates it.
Right.
In standard complex numbers, you have a variable, let's call it z, and you have its complex conjugate.
So if z is a plus b times I, the conjugate is a minus b times I. You just invert the sign of the imaginary component.
You've got it. Now, the foundational problem the author poses is the equation where z times its conjugate equals -1.
Wait, z times its conjugate equals -1. Let me think about the geometry of that for a second.
Sure, work it out.
In the standard Argand plane-like, the standard complex plane, when you multiply a number by its conjugate, you are calculating its modulus squared.
Right.
You're finding its absolute distance from the origin squared. And by basic Euclidean geometry, Pythagoras' theorem, a squared plus b squared cannot be a negative number.
It absolutely cannot.
It has to be 0 or positive.
You're tracking it perfectly. In a standard Euclidean manifold, distance squared is universally positive. So the equation z times its conjugate equals -1 is strictly impossible.
So how does the author get around that?
They take a really radical step. They define a canonical extension, which they denote as L sub 1.
Okay.
To make this impossible equation solvable, they introduce an entirely new basis vector to sit right alongside standard complex numbers, and they call it L sub 1.
But, you can't just drop a new vector into a mathematical system without defining how it behaves, right?
No, you have to write the rules.
Like if I'm inventing a new piece on a chessboard, I have to explain how it moves.
Yeah.
So what are the operational rules for this L sub 1?
Well, the rules are highly specific and honestly quite non-intuitive. The first rule is that L sub 1 squared equals 1.
Okay, that part seems ordinary enough.
It does. But the crucial deviation from standard algebra is that this new vector anti-commutes with complex scalars.
Anti-commute. So wait, if I have a complex scalar z, and I multiply it by L sub 1, the order actually matters.
Exactly.
Douglas times L sub 1 is not the same as L sub 1 times z. It would be equal to negative L sub 1 times z.
Yeah.
It completely flips the sign.
That is the core mechanical difference. In standard arithmetic, operations commute, 3 times 4 is 4 times 3.
Right.
But this non-commutative property fundamentally alters the topology of the space. And furthermore, To ensure the system remains internally consistent, specifically so that complex conjugation still acts as a proper mathematical involution, the author introduces a strict rule of hermeticity.
Hermeticity, meaning what exactly in this context? Because, like, hermeticity usually relates to matrices equaling their own conjugate transpose in quantum mechanics.
Yeah, it's a related concept. But here, hermeticity means that complex scalars are allowed to commute, meaning they can swap places with the new basis vectors, but only if the scalar undergoes conjugation during the swap.
Oh, I see.
So a scalar z times L sub 1 is equal to L sub 1 times the conjugate of z.
Okay, let me work through the implication of that. We have this weird new arena, L sub 1.
Right.
We have vectors that anti-commute and require conjugation to swap places. So if I take a generic element in this new space, say A plus B times L sub 1, and I multiply it by its conjugate.
What happened?
Because of those anti-commutation rules, the middle cross terms are going to have opposite signs.
Exactly.
They're going to just cancel each other out entirely.
They do. And what does that leave you with for the squared length of that element?
It leaves me with the first term squared, which is a times its conjugate, and then the last term weight.
Yep, you see it.
Because the L sub 1 squared is 1, but we had to apply the anti-commutation to get there. We don't get a squared plus b squared. We get a times its conjugate minus b times its conjugate. There it is.
We just generated negative distance. We generated the Minkowski metric.
That is the revelation right there. By intentionally breaking the rules of the standard complex plane and forcing L sub 1 into existence, the algebra organically generates a space where squared lengths can be negative.
Wow.
You've naturally derived the mathematical scaffolding of Einstein's spacetime?
That is just brilliant. And anyone listening who needs a quick grounding on that, the Minkowski metric is the geometry of special relativity.
Right.
Like in everyday 3D space, distance is calculated with all positive signs, up, down, left, right. But space-time treats time fundamentally differently than space.
It has to.
The mathematical distance between two events, the space-time interval, has a minus sign attached to the time component. Usually it's written as minus plus plus plus.
Exactly.
And that negative sign is what enforces the cosmic speed limit of light. And you're saying the author didn't import Einstein's physics. The physics just emerged from the anti-commutation rule of the algebra. The physics is a symptom of the algebra. And honestly, the implications go deeper. Consider the squared length we just derived, A times its conjugate minus B times its conjugate.
Okay.
What occurs if the values of A and B are mathematically identical?
Then you have a squared minus a squared. That's 0.
Right.
But the element itself isn't 0.
Right.
It has components, it has structure, but its total geometric length evaluates to 0.
In theoretical physics, we categorize those as light-like vectors.
Yeah.
A photon traveling through a vacuum moves along a null geodesic. Its space-time interval, the squared length of its path in the Minkowski metric, is exactly 0.
Right, right.
But in the context of this algebraic ring we're discussing, having a non-zero element with a squared length of 0 means it is a zero divisor.
A zero divisor, meaning it's a number that you can multiply by another non-zero number, and the result is 0.
Which breaks fundamental arithmetic.
Yeah. You can't divide by a zero divisor. It has no inverse.
It fundamentally cannot be inverted. The operation is simply undefined within the algebra.
Okay, let's translate that math back into physical reality. From a photon's perspective, due to relativistic time dilation, absolutely no proper time passes between the moment it is emitted from a star and the moment it hits your retina.
It's instantaneous for the photon.
Exactly. The journey is instantaneous. So is this mathematical inability to invert a light-like vector basically the algebraic equivalent of time stopping for a photon?
That is a deeply insightful way to conceptualize it. The algebra dictates the physical boundary conditions. The physical photon cannot experience time, and its mathematical representative lacks an inverse. The structure of the mathematics intrinsically embodies the relativistic behavior of light.
That's crazy.
Special relativity isn't a layer painted on top of this model. It is baked right into the fundamental rules of multiplication.
We started with an impossible arithmetic problem and accidentally derived the relativistic experience of a photon.
Pretty much.
But, you know, a universe isn't just a static grid of distances. For this to be a working cosmology, things have to move.
They do. Observers have to change reference frames.
Right. We need a mechanism for transformation within this bizarre space.
And that requires an architecture for coordinate shifts. In standard physics, the operation that allows you to chain reference frames while ensuring all observers agree on the speed of light, meaning they all agree on that space-time interval we just discussed.
That's a Lorentz transformation.
Exactly. The author introduces an equivalent, an orthogonal transformation they call capital lambda of x.
But to handle that, they have to expand the algebra, right? We can't just stay in L sub 1.
Correct. The author defines this transformation on a 5-dimensional subspace.
Correct.
They extend the algebraic basis vectors all the way up to L sub 4. And the specific formula proposed for the transformation is x times the quantity gamma minus gamma times v times L sub 4.
Let me visualize the components there. X times the quantity gamma minus gamma times v times L sub 4.
Right.
So x represents the position vector, v represents relative velocity, and gamma, well, that has to be the Lorentz factor.
It is.
The term that dictates how much time dilates and space contracts as you approach the speed of light.
It is the analog of the Lorentz factor, and the author imposes a strict condition to make this work. Gamma squared times the quantity 1 minus v squared must equal 1.
Okay, standard relativity stuff.
Because of this specific constraint, the transformation capital lambda of x is perfectly orthogonal.
Meaning it preserves lengths.
Exactly. It preserves the squared length of vectors regardless of the velocity v. It acts as a Lorentz-like transformation operating entirely within this non-commutative complex extension.
But what is the geometric consequence of actually applying that transformation?
What do you mean?
Like, if I take a chaotic mix of coordinates in this multidimensional space and I hit it with capital lambda of x, how does the space reorganize itself?
This is where the algebraic approach demonstrates its raw elegance. When you expand the transformation across the basis vectors, it acts kind of like a prism hitting white light.
Oh, interesting.
It naturally segregates the representation into two completely distinct sectors, based entirely on their structural properties.
It splits them by their mathematical signature.
Yes. The basis vectors literally organize themselves. You get a time-like sector characterized by a positive signature and a space-like sector characterized by a negative signature.
And that structural split gives us the foundation for actual tensor calculus.
It's the only way you can do the math.
By separating the time-like and space-like components so cleanly, the author is able to define a 4-position tensor. And crucially, they extract both the contravariant and covariant components.
The upper and lower indices.
Right, the upper index tensor, x upper mu, and the lower index tensor, x lower mu.
Which is absolutely essential for doing physics in anything other than a perfectly flat, static grid.
Yeah, for our listeners who might be a bit rusty on their differential geometry, think of it like navigating a mountain.
Good analogy.
The covariant components, the lower indices, they're like the contour lines on a topographical map. They tell you the steepness, the gradient, the shape of the terrain itself.
Right.
The contravariant components, the upper indices, are like the actual physical arrows pointing the direction you are walking up that mountain.
Exactly.
To calculate your actual trajectory in curved space-time, you need both. You need to know the shape of the space and your vector through it.
And the mathematical object that translates between the contour lines and the arrows, the operator that raises and lowers those indices to calculate actual distances, is the metric tensor.
And in this paper, the metric tensor isn't derived from mass curving space, like in Einstein's field equations.
No, not at all.
It just falls out of the algebra.
It emerges entirely from the separation of the time-like and space-like sectors.
That's wild.
The resulting metric tensor, denoted as G sub mu nu, is a diagonal matrix.
Okay.
The time-time component evaluates to -1 over v, and the 3 spatial components evaluate to v.
I really want to pause and underline how wild that is for you listening. In general relativity, the metric tensor is the holy grail.
It really is.
It describes the curvature of the entire universe. And to find it, you usually have to solve Einstein's field equations, which are notoriously brutal, nonlinear differential equations.
They relate the distribution of mass and energy directly to the curvature of spacetime.
Right. But here, the author didn't add gravity. They didn't plug in the mass of galaxies. The metric simply materialized from the algebraic rules of anti-commutation and orthogonality.
It is a purely geometric derivation of spacetime structure.
Fascinating.
And notice the formulation of that metric. It is entirely dependent on a single master parameter. V.
Okay.
The fundamental geometry of this universe, how space and time interact, stretch, and compress, is governed entirely by whatever that variable V is doing.
Okay, so V is the engine of the cosmos in this model. The entire shape of the universe scales with it.
Precisely.
But, our universe is dynamic, it expands. So what is V, and how does it actually evolve over time? This seems like the moment where pure, pristine algebra has to face the messy reality of observational cosmology.
This is exactly where the framework meets the physical universe, and frankly, where the most significant point of debate arises.
I bet.
To see if this mathematical universe resembles ours, the author calculates the scale factor.
By taking the inner product of those upper and lower index tensors we just mapped out.
Right. Taking that inner product yields the squared scaling factor, and the derived equation is a squared of t equals v of t over the quantity 1 minus v squared of t.
Let me repeat that for clarity.
Right.
A squared of t equals v of t over the quantity 1 minus v squared of t.
That's it.
The term A represents the scale factor.
Yeah.
It's the metric of cosmic expansion.
Mm.
If A is increasing as time moves forward, the universe is physically expanding, carrying galaxies apart.
Exactly.
And this equation states that the expansion of the universe is a direct function of the parameter V.
Right. And up to this stage, the author has constructed a rigorous, inescapable mathematical deduction. But an engine requires fuel. The equations tell us how the universe scales in relation to V, but they don't tell us what V actually is. To generate a cosmological timeline, the author has to introduce an assumption, an input. They postulate what they call a slow exponential profile for the behavior of V over time.
Okay, and they write the equation as V of t equals 1 minus the exponential of negative lambda t.
Yes. And just to simplify the analysis, they set the constant lambda equal to 1, rendering the profile simply V of t equals 1 minus the exponential of negative t.
Let's think about the shape of that curve.
Sure.
Why choose an exponential decay to limit? In physics, that kind of curve usually represents a system approaching an asymptotic boundary.
Like a hot cup of coffee cooling down to room temperature.
Exactly. Or a radioactive isotope decaying.
Yeah.
At time t equals 0, e to the 0 is 1. 1 minus 1 is 0. So v starts at absolute 0.
Correct.
As time progresses towards infinity, e to the negative t becomes a vanishingly small fraction, approaching 0. So v approaches 1 minus 0, which is 1. The parameter v starts at 0 and curves upward, slowly and exponentially approaching a hard limit of 1, but never truly reaching it.
That perfectly describes the mathematical behavior of the postulated profile. Now, the critical test is to plug that specific exponential curve back into the equation for the squared scaling factor.
To see what happens to the expansion of the universe when v behaves that way.
Exactly.
And the equation was a squared equals v over 1 minus v squared.
Right. When you execute that calculation and plot the resulting scale factor for positive time representing the history of the universe after the Big Bang, the curve qualitatively and numerically matches the consensus model of our actual universe.
The lambda CDM model. Lambda cold dark matter.
Yes.
Now,
the lambda CDM model is the absolute triumph of modern observational astronomy. It is synthesized from decades of measuring the cosmic microwave background radiation.
tracking the redshift of distant supernovae.
Exactly. And mapping the large-scale distribution of galactic clusters.
It describes a universe that originated in a dense state, expanded rapidly, experienced a period where the expansion slowed down due to the gravitational pull of matter.
And is currently in a phase of accelerated expansion.
Right. Driven by an unknown force we labeled dark energy, which is mathematically represented by the cosmological constant lambda.
And you are seeing the profound implications here. This purely algebraic model, fueled only by this simple exponential curve for V, recreates that exact complex expansion history.
That is just wow.
It does. At late times in the cosmic timeline, the author's algebraically derived curve perfectly asymptotes to the standard hyperbolic sine expressions, the sin functions that cosmologists rely on, to model the dark energy-dominated acceleration of the universe.
Okay, but the profound distinction here is that the author's model achieves this without ever invoking a cosmological constant.
Not once.
It doesn't rely on estimations of matter density or radiation pressure. It possesses absolutely no concept of dark energy.
None. The accelerated expansion is simply an emergent geometric property of the algebra acting on that exponential assumption for V.
That is deeply unsettling from a traditional physics perspective.
Oh, immensely.
I mean, physicists have spent decades trying to figure out the physical source of dark energy. Is it vacuum energy? Is it a new field? Is relativity breaking down on large scales?
And this paper suggests that dark energy might just be an illusion created by the intrinsic geometric algebra of the complex plane.
See, this is exactly where we need to introduce the critique from the Nate LM podcast,
Yes, we do.
because this is the weak point of the armor. We have an open letter from one Nate, and it's really vital we look at this impartially. We aren't taking sides here, but Nate raises a fundamental epistemological problem with how this result is actually achieved.
Nate's review is quite thorough. He begins by validating the architectural rigor of the paper.
He gives them credit.
Oh, absolutely. He explicitly applauds the mathematical sophistication required to assemble an 8-component algebra from first principles. He acknowledges that naturally generating a valid 4-position tensor and a working metric simply through algebraic extensions is a massive intellectual achievement.
Right, so he buys the engine. The internal logic of the geometric space is sound.
He absolutely buys the engine. His fierce critique is entirely focused on the fuel.
The V parameter.
Yes. Nate argues that the specific profile chosen for V, that exponential curve, is fundamentally flawed from a physics standpoint. He categorizes it as an ansatz pulled out of a hat.
An ansatz. For listeners not embedded in theoretical physics, an ansatz is essentially an educated guess.
Just a placeholder.
Yeah, it's an assumption you inject into a system of equations, often without underlying physical proofs, purely to see if it allows you to solve the math and match the experimental data.
Exactly. Nate's argument is that the author constructed this beautiful, pristine geometric structure, but then right at the finish line introduced a magical assumption.
There is no physical or mathematical justification provided in the paper for why the master parameter V must follow that specific exponential curve.
None. The author simply declares it, and lo and behold, the results match telescope data. Nate views this as reverse engineering the desired answer, rather than discovering a fundamental truth.
I could definitely see why a physicist would bristle at that. It feels a bit like drawing a target around the arrow after you've already shot it.
Yes.
But Nate does offer a historical comparison that contextualizes the use of an ansatz, doesn't he?
He does, and it's a very fair comparison. He compares the author's use of the exponential profile to Max Planck's introduction of the quantum.
Oh, that's high praise, actually.
It is. In the late 19th century, physics faced the ultraviolet catastrophe. Classical thermodynamics equations predicted that a black body in thermal equilibrium would emit infinite energy at high frequencies.
Which is obviously impossible.
Right. Planck spent years trying to solve it, derived from first principles, and failed.
Out of sheer desperation, he essentially hacks the math.
He introduced an ansatz. He assumed, without any physical justification at the time, that electromagnetic energy could only be emitted or absorbed in discrete, indivisible packets, which he called quanta.
It was a mathematical trick designed solely to force the equations to fit the observed experimental data of black body radiation.
Yes. Planck himself didn't fully believe it represented physical reality at first, but that trick turned out to be the foundational concept of quantum mechanics.
So Nate is acknowledging that an ansatz can be the vanguard of a revolution.
Exactly.
He's saying, I recognize the magic trick. It's a bold assumption, and maybe, like Planck, it points to a deeper reality we just don't understand yet. We cannot pretend it is a rigorous, derived conclusion. It remains a massive assumption.
That is precisely the epistemological gap Nate is highlighting. The algebra is rigorous. The input parameter is guessed.
Right.
We must be clear that Nate isn't declaring the author right or wrong. He is pointing out that until there is a physical derivation for why V must be exponential, the model is incomplete.
Which poses a massive question for you listening. Is this exponential profile just a mathematical sleight of hand? A convenient curve chosen specifically because it mimics the lambda CDM model?
Or does the underlying geometry of this extended complex plane actually demand that V behaves exponentially and the author simply hasn't found the proof yet?
Are we looking at a clever coincidence or a fundamental blueprint of reality?
It is the defining tension of the paper. However, the author's mathematical exploration doesn't stop at merely replicating our current universe.
No, it goes further.
If you possess an equation that dictates the scaling of space-time for positive values of 2 representing the history of the cosmos after the Big Bang, the immediate instinct of any mathematician is to explore the full domain of the function.
Like what happens when you input negative values for 2?
Exactly.
What happens if we run the cosmic clock backward past the Big Bang into negative coordinate time?
This exploration takes us into the negative regime, We take the established ansatz, v of t equals 1 minus the exponential of negative t, and evaluate it for negative time coordinates. Okay.
Because of the behavior of the exponential function, when it is negative, the term e to the negative t becomes greater than 1.
Because subtracting a negative is a positive, so it's e to a positive number.
Right. Consequently, the value of v of t becomes negative.
The master parameter of the universe's geometry drops below 0.
And that phase shift cascades mathematically through the entire algebraic structure. Recall the equation for the squared scaling factor. A squared of t equals v over the quantity 1 minus v squared.
I remember.
If we trace coordinate time backwards, something highly singular occurs at a very specific moment, exactly at t equals the negative natural logarithm of 2.
T equals negative lnn of 2.
At that precise mathematical coordinate, if you evaluate the exponential ansatz, v of t equals exactly negative 1.
Okay, let me plug negative 1 into the scaling equation.
Go for it.
The denominator is 1 minus v squared. If v is negative 1, v squared is 1. The denominator becomes 1 minus 1, which is 0. You are dividing by 0.
You reach a mathematical singularity.
But it's the behavior of the function around that singularity that is extraordinary. As you cross that point, the squared scaling function actually flips its mathematical sign. It transitions from positive to negative.
A negative squared scale factor.
Which means the entire metric signature of the universe undergoes a radical inversion.
The metric itself changes.
Yes. The metric we established earlier, which modeled standard Minkowski spacetime with a signature of minus plus plus plus, that entire signature flips. It becomes plus minus minus minus.
Let's slow down and really process the physical consequences of that.
It's massive.
In a metric signature, the signs dictate the fundamental nature of the dimensions. A negative sign on the time component enforces causality. It means time flows strictly in one direction. A cause must precede an effect.
Exactly.
The positive signs of the spatial dimensions mean you possess freedom of movement. You can travel forward and backward in space. If the mathematical framework suddenly flips those signs,
It shatters the causal structure of the universe.
literally shatters it.
In this negative time regime, specifically across the threshold of that singularity, the mathematical identities of the dimensions invert. Space adopts a time-like mathematical structure, and time adopts a space-like structure.
Imagine a hyperdimensional hourglass.
Oh, that's a good way to picture it.
Normally, we conceptualize time as the sand, pulled relentlessly downward by gravity through the narrow pinch in the middle. The physical glass bulb holding the sand represents the 3 dimensions of space.
Right.
In a standard model, the Big Bang is the pinch point and the sand just explodes out the other side.
Standard cosmology.
But in this geometric model, as the universe compresses backward toward that pinch point, the singularity at 2 equals negative ln of 2 cups. The sand doesn't merely flow through.
It can't.
The underlying mathematics dictating reality invert. The concept of falling sand and the concept of rigid glass swap identities as they squeeze through the singularity. Time becomes the rigid container, and space becomes the flowing, unidirectional constraint. The roles completely trade places.
That analogy captures the severity of the mathematical inversion perfectly. It is a complete structural reversal.
But does it stay that way?
No. As coordinate time continues to tick forward, recovering from this profound singularity and approaching t equals 0, the mathematics describes a transitionary boundary crossing. At exactly 2 equals 0, the metric dictates a state where all points in the manifold are at a null distance from one another.
Everything in the universe is mathematically separated by 0 distance.
The author describes it as a literal blink of time.
A blink of time.
And immediately following that blink, as coordinate time crosses into positive values, the squared scaling function regains its positive sign.
Back to normal.
The metric signature snaps back to the familiar minus plus 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 configuration. Causality is restored. The universe begins obeying the thermodynamic and relativistic laws we observe today.
But this violent structural flip in the metric at negative L of 2, it isn't framed as a failure of the model.
No, not at all.
The author isn't saying the math breaks down here. They're claiming this inversion is a feature, not a bug. They claim this specific causal flip is the exact mathematical mechanism required to support one of the most prominent and hotly debated alternative cosmologies in modern physics.
Indeed. They use this mathematical behavior to construct a rigorous framework for Sir Roger Penrose's conformal cyclic cosmology, commonly known as CCC.
We really need to ground the listener in Penrose's theory before we connect the math.
Absolutely.
Sir Roger Penrose, Nobel laureate, looked at the standard Big Bang model and identified a glaring, unresolved thermodynamic issue regarding entropy.
The entropy problem.
Right. The second law of thermodynamics dictates that the universe constantly moves toward higher entropy, more disorder, more mess. For the universe to exist in its current state, the initial state of the Big Bang had to possess unbelievably low, highly ordered entropy.
And Penrose's question was, why? What mechanism ordered the universe so perfectly at its origin?
Exactly. His solution is CCC. He hypothesized that the universe doesn't have a single beginning and end. Instead, it iterates through an infinite series of cycles, which he terms eons.
So the timeline from our Big Bang through our current present and into our infinite future constitutes merely one eon in an endless sequential chain.
Exactly. And the genius of Penrose's idea lies in how one eon connects to the next.
Right.
If you project our current universe quadrillions of years into the future, long after all the stars have burned out, eventually even the supermassive black holes will evaporate via Hawking radiation.
Empty.
All complex matter will decay into fundamental, massless particles, mostly photons. The universe will become an infinitely expanded, incredibly cold, featureless void dominated entirely by radiation.
This brings us back to our earlier discussion regarding light-like vectors. A universe filled solely with massless photons is a universe that fundamentally cannot experience time or measure distance.
Because a photon's internal clock does not tick?
Precisely. Without mass, you cannot construct a ruler to measure scale, or a clock to measure duration.
In that infinitely expanded empty future, the universe literally loses its physical sense of scale. It forgets how large it is.
In mathematical terms, its geometry becomes purely conformal.
Conformal geometry.
A conformal geometry is one where angles are preserved, the shape of things remains consistent, but the absolute scale becomes completely mathematically irrelevant.
A classic visualization would be like a fractal pattern or an MC Escher tiling.
Good example.
As you zoom infinitely inward or zoom infinitely outward, the localized geometric relationships remain identical. The scale changes, but the mathematical structure does not.
Penrose's profound insight was recognizing that mathematically an infinitely expanded hypercold conformal future universe is geometrically indistinguishable from a hyperdense, incredibly hot conformal Big Bang.
They are mathematically identical.
He proposed that the distant, decaying future of one eon mathematically transitions into the explosive Big Bang of the subsequent eon. The scale factor simply resets.
It's an incredibly elegant physical theory. But, it has always faced a massive theoretical hurdle, the math of the transition.
It's a huge problem.
How do you rigorously, mathematically stitch the infinite cold future of Eon A to the dense, hot beginning of Eon B? How do you cross the boundary when standard metrics break down at infinity and singularities?
And that is precisely the problem the author of our paper claims to have solved using their algebraic extension of the complex plane.
Using LSUB 1.
Let's examine the conformal match generated by their math. Look at the behavior of the metric as coordinate time approaches positive infinity, representing the deep final stages of our current eon.
Okay.
The exponential parameter v approaches 1. The scaling factor inflates toward infinity. Crucially, however, the underlying metric tensor asymptotically settles into the standard flat Minkowski spacetime metric, -1 + 1 + 1 + 1.
So the infinite future geometry is a flat standard spacetime. What about the geometry of the Big Bang in this model?
Within this algebraic framework, the Big Bang corresponds to that specific singularity we identified in the negative time regime.
The point at t equals negative natural log of 2.
Yes. And we establish what happens to the metric at that exact coordinate. It flips. The signature becomes +1, -1, -1, -1.
So the infinite future of the previous eon is mathematically characterized by a signature of -+++. The origin singularity of the new eon is characterized by plus, minus, minus, minus.
They are exact mathematical inverses of each other.
Which means they are perfectly conformal from a metric standpoint.
In differential geometry, two metrics are considered conformal if one is simply a scaled version of the other.
Right.
If you take the infinite future metric and multiply it entirely by -1, you yield the origin metric of the new eon. They are conformally identical if we allow the conformal scale factor squared, represented mathematically by capital omega squared, to equal -1.
But wait, omega squared equals -1. In standard general relativity, the conformal scale factor is a real number mapping the stretching of space.
True.
If you square any real number, the result must be positive. A squared scale factor of -1 implies that the scale factor itself is an imaginary number. Standard physics strictly prohibits an imaginary scale factor. It's considered unphysical.
It is entirely prohibited in standard real number manifolds. But consider the foundational premise of this entire paper.
Oh.
The author didn't build this universe in a standard manifold. They constructed it inside an extended algebraic space, explicitly engineered to solve the equation. Z times its conjugate equals -1.
Oh, wow.
They built a mathematical environment where lengths and scales squaring to negative numbers is the defining foundational rule.
The broken rule at the very beginning of the paper wasn't just an abstract mathematical exercise.
Not at all.
It was the specific tool required to unlock the boundary condition between universes. By embedding spacetime inside this generalized complex geometry, the math naturally permits a conformal scale factor squared to be -1.
The algebraic breaking of causality, that terrifying momentary inversion where space and time trade identities, acts as the exact geometric bridge necessary to traverse from one cosmic cycle to the next.
That is just incredible.
According to this mathematics, the geometric configuration of the universe at infinite positive time is fundamentally indistinguishable from its configuration at finite negative time during the singularity. The math seamlessly locks the end of one eon to the beginning of the next.
The implication of this is staggering. It suggests that the Big Bang wasn't an explosive physical event creating matter from nothing.
No.
It was a mathematical phase transition. It was the moment the universe's underlying geometric algebra flipped its conformal sign.
Within the rigorous logical constraints of the paper, that is the conclusion. The infinite future smoothly and inevitably transitions into the dense past, bridged by an algebraic inversion of causality.
It is a stunning, native mathematical realization of Penrose's grand vision, derived entirely from the decision to extend the complex number plane.
Truly.
But I need to process the reality of existing in that universe.
What do you mean?
If the mathematical coordinate time extends all the way backward toward -infinity, if there is a literal eternity of time stretching out before the Big Bang singularity occurs, does that mean an observer trapped in that previous universe would be waiting an infinite amount of time for the transition to happen?
Waiting forever.
Yeah. Would you just float in a cold void forever, waiting for the math to flip?
That is a profound physical paradox, and it is exactly the problem the author addresses in section 2 of the paper.
Oh, they actually address it.
They do. To resolve it, we must rigorously differentiate between coordinate time, which is merely a mathematical parameter on a grid, and proper time, which is the actual experiential time recorded by a physical clock or a conscious observer moving through that specific geometry.
Right. Einstein's relativity teaches us that time is not a universal background ticking at a constant rate. The time plotted on a mathematical graph is not the time experienced by a wristwatch moving through a gravitational field or accelerating.
Precisely. To understand the experience of transitioning between eons, we must calculate the proper time, denoted by the Greek letter tau, experienced by a hypothetical co-moving observer.
A co-moving observer is one who is stationary relative to the expansion of space. They are just floating along with the cosmic flow.
Exactly. The paper provides the calculus required to determine this. The infinitesimal change in proper time, tau, is defined as the square root of the absolute value of the squared scaling factor, a squared of t, multiplied by the infinitesimal change in coordinate time, dt.
Let me state that plainly so we can, hold the concept. The tiny slice of experienced time, d tau, is equal to the square root of the absolute value of the scale factor, multiplied by the tiny slice of mathematical time, dtt.
Yes. Therefore, to determine the total amount of time an observer experiences while waiting for the mathematical coordinate t to reach 0, we must set up a definite integral.
Okay, calculus time.
We must integrate that function starting from the coordinate time of -infinity all the way up to t equals 0.
So we are calculating the total area under the curve of experienced time, starting from an eternity in the past up to the present moment.
Exactly. But attempting to integrate a complex rational function containing exponentials buried inside a square root, evaluated from -infinity, it is mathematically treacherous.
I can imagine.
To manage this, the author employs a standard technique, integration by substitution. They define a new variable, x, and set it equal to the exponential of the coordinate time, t.
X equals e to the power of t.
Right. When you execute a substitution, you must remap the boundaries of your integral. Let's look at the lower bound. As coordinate time t stretches back toward negative infinity, the expression e to the negative infinity mathematically approaches 0.
Okay.
Thus, our new lower bound for x is 0. Now for the upper bound. When coordinate time t reaches 0, e to the power of 0 is exactly 1. So our new upper bound for x is 1.
Oh, that substitution is a brilliant trick. The integral originally spanned an infinite timeline, from negative infinity to 0. By substituting x, we map that entire infinite mathematical eternity onto a finite, bounded segment between 0 and 1.
It confines the infinite domain. Now we must substitute the variables inside the integrand itself. I will abstract the raw algebraic manipulation, but once you substitute x into the scaling factor equation, the new integrand becomes the square root of the absolute value of the quantity x minus 1 divided by the quantity x times 2x minus 1.
Okay, the actual formula is less important than its behavior.
Yeah.
We have a function, and we are trying to find the area under it between 0 and 1. To know if that area is finite or infinite, to know if the observer waits forever or not, we have to look for places where the function breaks down. We have to look for singularities where the denominator becomes 0, causing the graph of the function to spike violently toward infinity.
And do you see any?
Looking at that denominator, it was x times the quantity 2x minus 1. We are going to have a mathematical crisis when x is 0.
Yes.
And we will have another crisis when 2x minus 1 equals 0, which occurs when x equals exactly 1/2.
Your deduction is flawless. We have identified two singularities residing within our integration boundaries. X equals 0 and x equals 1/2. So what happens? The survival of the observer depends on the mathematical nature of these singularities. Let's analyze the behavior as x approaches 0 from the positive side. At this boundary, the function's behavior is overwhelmingly dominated by the isolated 1 over x term trapped inside the square root.
Okay.
The function essentially behaves like 1 divided by the square root of x.
And this is where the physical interpretation of calculus really matters.
It does.
If the function behaved like 1 divided by x, the area under that spike as it goes to infinity would also be infinite. The integral would diverge.
Right.
But a function behaving like 1 divided by the square root of x is different. It spikes to infinity, yes, but the spike narrows so rapidly that the total area contained underneath it remains mathematically finite.
Exactly.
Think of it like Zeno's paradox, or painting an infinitely long wall. If every minute you paint half the distance of the previous minute, you can paint an infinitely long line using a finite amount of paint. The math converges.
That is an excellent way to abstract the concept. Because the singularity behaves specifically like 1 over the square root of x, the area converges.
So it's finite.
The singularity at the origin of our mapped interval is absolutely integrable. It yields a finite value.
But what about the other singularity?
Now, we must evaluate the second singularity, located at x equals 1/2. As the value of x encroaches infinitesimally close to 1/2, the term 2x minus 1 vanishes linearly. Consequently, inside the square root, the dominant behavior mimics 1 divided by the absolute value of x minus 1/2.
So it's the exact same geometric behavior. The entire complex function simplifies near that singularity to behave like a constant multiplied by 1 over the square root of the distance to the singularity.
Exactly. And relying on the identical calculus principle we just discussed, a 1 over square root singularity is unconditionally integrable.
Amazing.
The mathematical graph violently spikes to infinity at x equals 1/2, but the geometric spike is so impossibly thin that the total area accumulating underneath it is a rigorously finite number.
And the upper bound.
Finally, near the upper boundary where x equals 1, the function gracefully simplifies to behave like the square root of 1 minus x, which evaluates to 0 and is perfectly well behaved.
So, synthesizing all that calculus, what is the ultimate physical conclusion for our observer?
The mathematical conclusion dictates reality. Because every singularity within the map domain is demonstrably integrable, the total area calculated by the integral is finite. The function is absolutely integrable across the entire span.
Wow.
Therefore, the total proper time experienced by a physical, co-moving observer, waiting from a coordinate time of negative infinity all the way to the boundary crossing at t equals 0, is a strictly finite amount of time.
I really want to make sure you grasp the beautiful contradiction derived here. Coordinate time, the mathematical grid underlying the universe, stretches back literally forever.
The timeline is infinite.
But a physical consciousness, an observer constrained by the geometry of this space, experiences an entirely different reality. You wouldn't be floating in a cold, dead void for an eternity waiting for the eons to shift.
No, you wouldn't.
The geometry dictates that your clock would only tick a finite number of times before the universe inverted its causality, space, and time swap roles, and the mathematical framework birthed the next Big Bang.
The mathematics elegantly resolves the paradox of an eternal past. The framework explicitly permits an infinite mathematical regression of coordinate history, yet simultaneously preserves a finite experiential reality for any physical entity inhabiting that history.
It's just brilliant.
The geometry forces eternity to feel finite.
It's deeply poetic that a resolution to such a massive existential and physical paradox is derived purely from proving the integrability of square roots.
It highlights the unreasonable effectiveness of mathematics. When pure algebraic logic organically aligns to solve complex physical and philosophical boundary conditions, it is a truly compelling architecture.
Let's pull back and review the massive arc we've traced today. We began by examining a single, seemingly impossible mathematical premise, a complex number multiplied by its conjugate equating to -1. By inventing a canonical extension, L sub 1, to validate that equation, the author constructed an 8-dimensional geometric algebra. That specific algebra inherently split into time-like and space-like components, organically generating the metric tensor of space-time without requiring gravity or mass.
Following that structural derivation, the author introduced an exponential ansatz for the master geometric parameter.
The V profile.
Exactly. That single assumption caused the algebraic metric to perfectly replicate the exact expansion rate of our observable universe, matching the lambda CDM model's late-stage acceleration without needing to invent dark energy or a cosmological constant.
And when we pushed that same validated metric backward into the negative time regime, the math revealed a singularity that radically inverts the causal structure of space and time, mathematically providing the exact conformal bridge required to connect the eons in Roger Penrose's cyclical conformal cosmology.
All while the calculus ensured that anyone living through that mathematically infinite cycle only physically endures a finite span of time.
From a single shattered rule of basic arithmetic, an entire mathematically consistent, eternal, cyclical cosmos was generated.
Regardless of the debate surrounding the ansatz, it is a magnificent piece of theoretical construction.
It is a profound model.
Yeah.
But I want to leave you with a lingering thought, a question to ponder when you think about the nature of time and geometry.
There's always one more question.
Always. We've seen how proper time remains finite, even when the mathematical timeline stretches to infinity. We've seen how the algebraic metric violently flips, tearing down the boundary of causality to mathematically stitch our universe to the dead universe that preceded it.
Right.
But if our current reality is merely one eon, mathematically fused to the next via this conformal sign flip, what happens to the information? When causality shatters and space and time swap identities at the boundary, does anything survive the crossing? If the mathematical structure perfectly resets to a pristine, conformal geometric state to launch the next Big Bang, is there any structural footprint left behind in the complex plane to prove the previous eons ever existed?
That's the real mystery.
Or is the universe a perfect amnesiac machine doomed to perfectly recreate itself while instantly forgetting its own infinite history the very moment time begins again?
That remains the ultimate terrifying question of all cyclic cosmologies. Does the underlying geometry possess a memory?
Thank you for joining us on this deep dive into the architecture of the cosmos. If you are captivated by the debate over the exponential ansatz and want to explore the philosophical line between a mathematical trick and a physical truth, I highly recommend checking out the Nate LM podcast as requested by the source material. Until next time, remember sometimes to understand the rules of the universe, you first have to figure out how to break them. Stay curious.